Okay, Newton's second law is this law. You already know the equation. Force equals mass times acceleration. And we played a game on Friday that looked at those letters. Okay, what is force measured in? What do we measure force in? Huh? Newtons, that's right. So we measure it in newtons. Okay, and force is equal to, so it's force is equal to mass times acceleration. All right, mass we measure in kilograms, and acceleration we measure in meters per second. Otherwise, we write that as this, meters per second squared. If I have a ramp that looks like this, what is the speed of the cart doing from here to there? What is it doing? Why aren't you seeing anything? There it is. It's accelerating. What does that mean? Huh? So its speed is going up. How can you measure that? In meters. Huh? But if we just said meters per second, would that be speed? So the speed from there to there would be different than the speed from the green to the yellow. Everybody with me on that? So the speed changes. Everybody follow me on that? So that's how we get meters per second, because this first time is going slow, right? You guys with me? Then the next chunk, it's going faster and faster. So every second that goes by, the cart is going faster. You cool with that? So that's why we say meters per second squared. We measure speed in meters per second. And we measure acceleration in meters per second for the time. So could something increase for 1 minute? Could it continue to increase for a minute? Could something continue to increase for an hour? That's right. So look at this. I could draw a graph that shows that. If this is distance and this is time, there's an increase, isn't there, guys? So we're showing an increase. So does that make sense? Does the unit really make sense to you right now, guys? Why is it meters per second squared? I want you to write down a sentence in your notes that describes why it's meters per second squared. So understanding it is one thing, being able to write it down and show that you truly understand it is another. So I'll help you out if you need a little more help. The speed increases every single second. So we're comparing speed to the time. If the speed increases every second, we have an acceleration. You with me? So an acceleration is a change in speed over time. We're measuring time with seconds. here's the tricky part. Well, I'll give you a second. Stop this for a second. What happens on our tracks now from here to here? It slows down. The speed slows down, right? So you know what we actually call that? Yeah, deceleration or negative acceleration. Because the speed is changing over time, but just negatively it's going down. Everybody with me on that? So also add that acceleration, there's positive acceleration and then there's negative acceleration. And in my notes, I'm going to jot down there it's either positive or negative. Now, there's also a third component to this. I'll let you guys jot that down. I'll come back in a second. Okay, Melody, say what you say again.
Changing speed or direction.
Speed or direction. So have we talked about the two type ways to change speed? Guys, gals, folks, did we talk about two ways to change speed? It could go up or it could go down, right? So what's the third way that we could change velocity? Melody.
Staying at the same speed.
Same speed and changing direction. You guys with me? An acceleration is a change in velocity. So the third way to change velocity is to change direction. Everybody cool with that idea? So, you know the marble lab that we're doing? In the circle one? You guys all know that one that I'm talking about?
Oh, yes.
It's got a track like this. Let me just move this. I'll shrink this down a little bit. Okay, the ring that goes like this. Here's the ring, and then the marble will go around and around and around and around. And then ultimately, you know, once we change the track and go like this, then it's going to go whoop in a straight line. Everybody with me on that? So when it's going in a circle around that track, what's happening to its velocity? Let's say the speed stays the same. What's happening to its velocity? Is it remaining constant? Talk in your pods quickly. All right, so I got this video in here, and I want to show everybody this, so you guys here and everybody at home too, if anybody's even watching it. So as the marble goes around, I'm just going to give it a quick whip. Okay. Let's get rid of that baby now. All right. In what ways did that marble change in velocity? It slowed down. So that marble around the track slowed down. So it had a negative change in speed. What else? What was this direction? Huh? The direction didn't change? Really?
Well, it did.
Well, look at this. If I do this marble, Let me put that back up here again. Let's just watch this again. Let's just do this again here. You guys are all doing this, you know, at school right now. A lot of you guys are. So let's just do this and just see what happens. Okay? All right, so I'll set this baby like this. Can everybody see it? Okay, so last time it was closed. It was a closed track. And it continued to go in a circle. And now it didn't. It didn't. It went in a circle, so let me get my pen up here. Let me get a different color. It went in a circle and then went straight. So when it's going in a circle, what's happening to its direction? It's changing. And we can see it constantly changes there, doesn't it? So when something's in orbit, it's constantly changing its velocity. Its speed might maintain the same, but its direction is always changing. Everybody cool with that? So that's kind of part of Newton's second law, is that it can change in speed, it can change in direction. Both are forms of acceleration. A negative acceleration, a positive acceleration, or change in direction. So the bigger idea, or the easier idea to understand, is that force equals mass times acceleration. Okay? Well, we know force is a push or pull. Correct, Mundo? All right? And then if something's bigger, if something's bigger, and it increases at the same rate, the speed increases at the same rate as something smaller, what does it need more of? Okay, you got a little sports car, and you got a huge Mack truck or train, and if they accelerate the same, what does the train need to keep up to the sports car? More. It has more mass, so it needs more force. So if the speed is going to be the same, or the acceleration is the same, and the mass is different, the one with a bigger mass needs more force. Everybody cool with that? All right? And so that's how they're related as well. Cool with that? So that's where the mass and acceleration are also related. So there's a couple of different things going on here. And so you guys can show that, and you can demonstrate that, you know, with a lot of different tools, okay? So force equals mass times acceleration relates to the relationship between the three things. The more force you have, the more you're going to accelerate. Everybody with me on that? The more mass you need, the more force you need to accelerate. Right? If you want a ton of acceleration, there's two ways to get a ton of acceleration. What are the two ways? Well, you change force and you change mass. So if you want to increase acceleration, what are you going to change to the force? More, less, or the same amount of force? You need more force. Okay? What if you can't change the force? What are you going to do? Less mass, right. Less mass. Does that make sense, everybody? Jot some ideas down in your notes, and then that is it for the day today. We're going to do Newton's third law tomorrow. Got it?